Hello, Math 1050. This is section 5.5, Systems of Inequalities in Two Variables. So we've been doing a lot of algebraic computation with our systems, but now we're going to kind of switch to graphing with our systems. We've got 4 topics here. So we're graphing not equations, but inequalities, which means we're going to be shading. So our first topic is just to practice graphing an inequality, and we'll get to the systems in a minute. So our equation that we're going to graph first is this one, x squared plus y is less than or equal to 4. So in this equation, we want to isolate our y. So if we subtract the x squared, we have y is less than or equal to negative x squared plus 4. So to graph an inequality, you graph the related equation. So we're going to graph y equals negative x squared plus 4. And then what's different between this inequality and this equation is that the inequality we need to shade. We're finding not a particular solution value or a particular graph, but we're finding a region that the whole region of the coordinate plane where y is less than negative x squared plus 4. So this shape is a parabola. It opens downward because of the negative. It's reflected, and then it's shifted up 4 units. So our vertex is here at 0, 4, and we can use, a graphing 1-3-5 pattern to get our shape. In ALEKS, it'll probably just need you to put a couple points, but you are experts at graphing in ALEKS. So with inequalities, we have to think about if we want our boundary to be a solid boundary that's included or a dotted boundary that is not included. So if you see a strict inequality like this, or like this, that is going to be a dashed line or a dashed boundary. And if you see less than or equal to or greater than or equal to, that's going to be a solid boundary. ALEKS just has a button that you can click on to switch between dotted and solid. So our parabola is just a solid boundary. So the parabola represents all of the values for which y is equal to negative x squared plus 4. Our inequality is that we want to shade and show the region where the y values are less than negative x squared plus 4. So we want to shade anything that is below the parabola. So we would shade inside. Another way that you can decide about which region is your solution region is that you can use a test point. So you would either test, up here above the parabola somewhere in this region, and you would test inside to see which one. So I might pick the origin as my test point if you like doing it this way, and you would just substitute those values into the equation and see if it's true. So 0 squared plus 0 less than or equal to 4, and that's 0 less than or equal to 4, and that's true. So we should shade where the whole region where the origin 0, 0 is. So if you like just thinking about above and below for the shading, that's fine. We'll have a variation with x's, but if you prefer to do a test point, you can do that as well. So here's just another one to practice. This is y is less than x squared minus 5. So this is another parabola, but it opens upward and it's shifted down 5. So the vertex is here. So when you're graphing it, this is an example of one where you will have to click on that boundary change. So this has to be a not included boundary. We need it to be dashed, so use that button. We want all the y values less than, so that means we're going to shade below. Or if you prefer to use test point you can. So shading below the parabola means that our region includes all of these points. Oh, not very good. Love it when you're shading like basically the whole coordinate plane, huh? Okay, so that's our solution space. Okay, so our main purpose this unit is to work with systems. Well, if you're graphing a system of inequalities, it just means you have more than one equation that you're dealing with, and you're looking for the region that is true for both equations. So this is two lines. So I'm going to graph the first line in blue. It has a y-intercept of 3, and the slope is -4, so down 4/1. So we've got a line here, and we want this to be not a solid line, but a dashed line. Okay. Might as well use the tools that it gives me, huh? So that's our first equation. Now, if we were to shade it, we would choose the region that is below, y greater than, above. We would shade above that line, so everything that's above it. Our second equation, I'm going to mark or graph in green. So it has a y-intercept of -5, and the slope is 3 up 3/1. And this one is also a dashed line. And for our shading on this one, this is a y less than equation, so we need to shade below. So we need to figure out which of our 4 regions. So those two lines break up the coordinate plane into 4 regions, 1, 2, 3, 4. And we need to figure out which of the regions that is the correct solution space. So you can use test points if you want. I just like to think about above and below. We're trying to shade everything that's above the blue line and everything that's below the green line. So our solution space is which parts of the plane both of those things are true in. So our solution space is going to be this space over here. And so I'm going to erase this because I don't want to think it is part of the solution space, because that was those two regions, it was only true for one of the equations, not both. Okay, that's our first system. That's a linear system. I'm going to do one more just in case. So this first one I'll graph in blue. Has a y-intercept of 3 and a slope of -2. And that one is a dashed line, not solid, because we do not want to include that boundary. Our next one is a y-intercept of 7 and a slope of 3. And this one is going to be a solid line because it is y is greater than or equal to. Okay. Oh, well, that was not the tool, that was my scribbly pen. Close enough. That's a straight line, so straight. Okay, so our boundary, the region that we want to shade, above the blue line, above the green line, above both of them, so that would be here. Wow, good shading. I am really doing a great job with these. Try not to go outside your boundary. It's so much easier on Alex because you just click on which region you want. Okay, so the next topic is going to be a system with 3 linear equations. And oftentimes when we have a system of 3, one of them or 2 of them are horizontal or vertical lines. So I wanted to review that and show you an example of that. And then we'll try the system with 3 equations. So if you have an equation like x is greater than 2, that is a vertical line. And the greater than 2 means that we would shade to the right of 2. So for x's and y's, we have to think right and left instead of above and below. And if you had an equation like x is less than 2, that would be to the left of 2. Kind of like if you were dealing with a number line, you've got your 2, and so greater than would be to the right and less than would be to the left. For horizontal lines, we might have the equation y is greater than 2 or y is less than 2, and we would shade above or below that line where y is equal to 2. So here is a system that has 3 equations. So we have x greater than 0, we have y greater than or equal to 0, and we have negative 3x plus 2y less than 6. So I'm going to graph this one first, x is greater than 0. Well, x is greater than 0 is a vertical line. It has an undefined slope. And it's a dashed line because it is strictly greater than. And it's greater than 0, so we would shade everything to the right. I'm just going to put an arrow to remind me. Our second equation that I'm going to graph is y is greater than 0. Well, y equals 0 is this horizontal line going through the origin. Is a solid line, and we want to shade everything above it. So it looks like so far my solution space is this quadrant 1. But we do have one more equation. Our last equation, I need to solve for y. So if I solve for y, we have 2y is less than negative 3x plus 6. So if we divide, it's negative 3/2 x plus 3. So our y-intercept is 3 and our slope is negative 3/2. Oh my goodness. That's a positive. I'm not changing the video. I caught it. Positive 3/2 x. When I added the 3x, that should have been positive. So again, y-intercept 3, up 3 over 2 for the slope. Okay, so we need to think about how we need to shade this line. It is a dashed line, not solid. So we need to think about, is our shading going to be above or below? Well, this is y is less than, so it's going to be below that dashed line. So like everything over here. So what that means for our solution space, it has to be above the green line, it has to be to the right of the blue line, and it has to be below the black line. So we just have this region over here. And in Alex, you'll just have to click on the region that you want shaded. Okay, that's our region. Don't always assume it's the bounded region. We do have a bounded region right here, this triangle, but that's not our solution space. We have this one over here. And so it could be, when you first graph it, it really could be any of those regions. This has 1, 2, 3, 4, 5, 6, 7 different regions that have been sort of divided up by those equations, and your solution space is going to be one of those. Okay, here's another one to practice. X greater than negative 4. So that's a vertical line here, dashed. Greater than means we're going to be shading to the right. We have y is less than or equal to negative 3x minus 5. So here's our intercept of negative 5, and our slope is negative 3. And this one is going to be a solid line. It's easier to draw a straight line on a smartboard than it is on a tablet. Okay, and for that one, it's y is less than, so it's going to be below. And then our last line, y is greater than 3x plus 4. Here's our intercept, and our slope is positive 3. Whoops. And that one is also a dashed line. And for that one, we're going to shade above, because y is greater than. So above the red line, below the green line, and to the right of the blue line. This one is a bounded region. And that's it. Okay, system of 3 linear equations. Our last topic is to graph a system of non-linear inequalities. So we might have circles come up, we might have parabolas come up. This first one is a circle. So it's a circle centered at the origin. So remember, sometimes circles are shifted to the left or to the right. But this one is centered right on the origin. So the radius squared is 4, so we need to count out 2 in each direction from the center to get our circle. And this circle is a solid line. It could be dashed if it did not have that equality with it, but this one is a solid line. Good circle. Okay, for circles, it's kind of interesting. If it's less than r squared, that's inside the circle. And if it's x squared plus y squared greater than the radius squared, that's outside. So for ours, we're going to be shading inside the circle. So we also have a line in our system. X plus y is greater than negative 1. So if we solve for y, this is y is greater than negative x minus 1. So our y-intercept is negative 1, and our slope is down 1 over 1. Now this is not a solid line. It's just going to be a dashed line. My pen stopped working. Oh, I think it's back. Oh. Wow, I do not know what is happening. Look at that. My pen is struggling. Okay. Great. You know what? I'm just leaving this all in the video. Let's see if I can draw a line with my pen. Oh, I can. Blessed. Okay. So we need to shade above the green dotted line, and we need to shade inside the circle. So our solution space, no, I'm not going to be able to do it because some funky weird thing is happening on my tablet. I'm going to put a heart in the region that we need to shade. It's this region. Oh my gosh. Look on the notes that I put in the PDF files. Okay, and I think I have another example, but I don't think I can do it because my pen is dying. It's really cool though. I just don't know why it's doing that. Anywho, if you want to see this example, look in the notes. It's a parabola and a line, and if you're having problems with it, just let me know and I will help you with it. Just email me. I don't know what's wrong with my pen, but graphing is done for the day. So thank you.